Hello, my name is Yasmin Landa. I am a fourth year at the University of Washington studying psychology and sociology. I'm currently studying statistical learning in bilingual language development with Dr. Pratt. I will be discussing humans' innate predisposition of statistical learning in language development with a focus on bilingualism and the influence of environmental factors. Statistical learning are predispositions based on pattern recognition from varied inputs. It is a generalized learning method that is used in many areas of study, such as science and finance. It is implicit, meaning that an individual learns without conscious awareness that they are doing so. Statistical learning was first discovered in Jenny Saffron et al.'s study on language acquisition in 8-month-old infants. The depiction on the right illustrates the team's approach to studying brain responses in infants through the use of an MEG. In order to grasp a better understanding of statistical learning in language, let's do a similar activity to that which was given to the 8-month-old infants in the study. The following activity demonstrates statistical learning in language. Please follow along by reading this sentence in your head 5 times while I say it out loud. Li da ti, li bi ti, da bi li ti bi. Li da ti, li bi ti, da bi li ti bi. Li da ti, li bi ti, da bi li ti bi. Li da ti, li bi ti, da bi li ti bi. Li da ti, li bi ti, da bi li ti bi. Now please look at the following 2-syllable sequences, which corresponds to the above sentence. If you chose da ti bi, then you are correct. And you might be questioning why you were able to discern the correct answer from a sentence of seemingly random gibberish. That is because your brain was engaging in pattern recognition through statistical learning. If you take a moment to examine the sentence above, you will see that T has come after da before, and B has come after T before. However, da has never come after li, and li has never come after da. Hence, the correct answer is ta db. A baby who is a monolingual English learner uses statistical learning at different levels, starting from the least information to the most. There is acoustic phonetics, which deals with frequencies and amplitudes of language. Phonotactics, which refers to the sequence of sounds. Prosodic, such as duration and pitch. Word, which entails vocabulary. And lastly, syntax, which encompasses grammar and phrases. However, in a baby that is a bilingual English and Spanish learner, this happens for both languages. A bilingual baby needs to distinguish between English and Spanish through pattern recognition, rather than just seeing it as one big language. Thus, statistical learning operates differently in bilinguals. Consequently, my research question is as follows. What are key environmental factors that influence statistical learning in bilinguals? Secondary research questions ask about the influence of certain environmental factors on statistical learning, such as the age of language acquisition. From previous studies, we know that neuroplasticity decreases with age, making it more difficult for adults to learn additional languages. Therefore, does the age of acquisition affect statistical learning mechanisms? We also know that the structure of a native language shapes speech perception, an important aspect of statistical learning. So how does native language influence statistical learning? My research methods consist of examining 10 peer-reviewed articles on statistical language in bilingualism. I began by looking at relevant databases such as education, linguistic, and psychology journals, while focusing on leading researchers in the field. Additionally, I looked at the populations being studied and along with it the variety in environmental factors. Were they infants or adults? Which languages were being studied? And were they native to the subjects? Lastly, I looked at their findings and implications. What did they conclude and what further questions arose? One major finding was that early language experience enhances secondary language, statistical learning, intonal language, and word segmentation, meaning that an individual's early experience with a similar native language to that of their secondary one enhances their statistical learning in these areas. And lastly, early bilingualism strengthens the ability to learn novel statistical relations, illustrating that an individual who has learned two languages at a young age can learn new language patterns easier. So what are the implications of this research? This research can help create better informed language teaching models in the education system by understanding the way statistical learning works in bilinguals and the effects of environmental factors. By understanding these, models specifically geared for the bilingual brain can be created and existing ones such as the English as a Second Language Program, or ESL, can be modified. Lastly, this research can enhance language rehabilitation clinical models for bilinguals, such as the work Mary Alt, an associate professor in the Department of Speech, Language, and Hearing Sciences at the University of Arizona, is doing by applying statistical learning methods to speech pathology to help enhance her clients' learning. By understanding the mechanisms of statistical learning in bilinguals, we can create a better, more inclusive world. Thank you. I'd like to give a special thanks to my McNair advisor, Quinn Schran, and the other faculty in the program, as well as my research mentor, Dr. Chantal Pratt, and the McNair program itself for providing funding for this academic research project. Here is my bibliography.